Okay, so this is the first lesson of the new unit. It is 7.1, finding all 6 trig ratios, okay? And this is actually a review of stuff that you learned in geometry. If you remember SOHCAHTOA, that's basically what we are reviewing, okay? So the one note that we're going to write is that we use trig ratios to compare sides of a right triangle, right? We only can do these trig ratios when we have a right triangle. A right triangle is a triangle that has a 90-degree angle, right? And so there are 3 really common trig ratios that you've already learned. Those are sine, cosine, and tan. And the easiest way to remember it is if you remember SOHCAHTOA, right? And so remember the first letter, in this case it's S, that means sine. The O means opposite, and then the H means hypotenuse, right? So sine equals opposite over hypotenuse. For the second one, the C stands for cosine, and that is, the A stands for adjacent over the H is hypotenuse. And then lastly, we have the T, that stands for tan, and we have, again, tan is opposite over adjacent, right? Because it's O over A. And so those are the 3 most common trig ratios. There are actually 3 other trig ratios that you're just going to write in your notebook just so that you have, okay? And they're actually the opposite of sine, cosine, and tan. So the opposite of sine is what we call cosecant. So I'm just going to write it here, cosecant, and it's often abbreviated as CSC. So it's actually the opposite of sine. So instead of it being opposite over hypotenuse, it's hypotenuse over opposite. The opposite of cosine is secant, okay, also known as SEC. So again, it's the opposite of cosine, meaning we're going to flip these, okay? So we have hypotenuse over adjacent. And then lastly, the opposite of tangent is cotangent, okay? That's COT. And it's the opposite of tangent, so instead of O over A, it's adjacent over opposite. Okay, so these are like the 6 trig ratios now that you know. And in a right triangle, we can actually identify these ratios. Okay, so I want you to draw a right triangle like this. There's the right angle. And I want you to make sure you're writing it down exactly like I do with the vertices. And then we're going to make this side 9, this side 12, and this side 15. Okay, so let's say we wanted to find the cosine of u, okay? So first thing you want to identify is cosine is adjacent over hypotenuse, okay? So we need to figure out what is the adjacent and hypotenuse according to angle u. So this u tells you you're focusing on u. So I'm going to label the sides based on u. Now the easiest for me to identify first is the hypotenuse, right? That's always across from the 90-degree angle. Then I like to identify the opposite. The opposite is always the side across from the angle you circled. So in this case, the opposite is 9, which means the one that's left is adjacent. So 12 is adjacent. So cosine of u is adjacent over hypotenuse, while my adjacent is 12 and my hypotenuse is 15. And you can what am I trying to say? You can simplify this fraction to get 4 over 5. Okay? Now let's find tan of u. So tan is opposite over adjacent. So my opposite is 9 and my adjacent is 12. Again, I can simplify that to 3 over 4. Now let's find the sine of w. If you notice, we're now dealing with w instead of u, which means we're actually going to have to relabel our triangle because it's different now, okay? So now we're focusing on w, which I've circled right here. If you notice, your hypotenuse actually stays the same, right? It's across from the 90-degree angle. But now, I'll change the color. The opposite is opposite of w. Okay, so this is still the hypotenuse. Opposite of w is now the 12. and then the 9 is the adjacent, okay? So the labeling changes based on the angle that you're looking at. So sine is opposite over hypotenuse. So my opposite is 12, my hypotenuse is 15, so I can simplify that to 4 over 5. And then lastly, let's say I wanted to find the secant of W. If you look above, secant is right here. That's hypotenuse over adjacent. So my hypotenuse is 15, my adjacent is 9, and I can simplify that to 5 over 3. Okay? So hopefully this is review, right? And so what I want to quickly go through, though, is let's say you have a right triangle. So draw this again. We're going to draw a right triangle like this. I'm going to call it X, Y, and Z. And I'm going to call it 20. I'm going to give this side 24, and this side is going to be 30. Okay? So let's say we're trying to find, this is a 2, by the way. Let's say I'm trying to find the tan of X. Okay? So X is right here. My hypotenuse is here, my opposite is this blank side, and my adjacent is the 24. Now, according to SOHCAHTOA, right, tan is opposite over adjacent. And if you notice, I know my adjacent, but I don't know my opposite, okay? So when we need to solve for a missing side, I'm going to write this here, to solve for a missing side, use Pythag, okay? And remember, Pythag is a squared plus b squared equals c squared. And the biggest thing to remember is c is always a hypotenuse. As long as you identify c correctly, a and b don't matter, okay? So I'm going to label my hypotenuse as c, and then I'm going to decide that 24 is a, the side that I don't know is b. So I can write this as 24 squared plus b squared equals 30 squared. I can simplify this, so this is 576 plus b squared equals 900. And now you're just going to solve for b. So I'm going to subtract by 576 on both sides. So b squared is going to equal 324. And remember, to get rid of a square, you square root. So b is 18. Okay, if you put that in your calculator. So now I know this side is 18. So now, going back to the original problem, I can now find the tan of x, right? Because it's opposite over adjacent. And again, I can simplify this to 3 over 4. Okay, move on to practice.